In this video, I'm going to show you a basic example of how you can overload the subscript operator. This is not an operator that you'll overload often, but I'm showing you this just in case you need it, and also if you happen to come across it in someone else's code. When overloading the subscript operator, it must be defined as a non-static member function. This is a weird one. It's considered a binary operator. It takes in a single argument and is going to return by reference as opposed to returning by value. And that will allow you to use the subscript on either side of the assignment operator. Okay, so whether you want to set a value or whether you want to fetch a value. And here's an example of a subscript operator member function declaration. You have the return type, again it returns by reference, and then operator, the subscript operator, and that takes in a value, typically an integer, to keep track of the index. Okay, I have a quick example for you in Visual Studio using the entity class again. In the public section, you can see I have a constructor, and this is going to take in a size, and that size is going to determine the amount of elements for a dynamic array on the heap. I'll just scroll down here to the private section. I have two variables here. One is a pointer to an integer called element, and that is going to point to a dynamic array on the heap, and upper bound, which is going to represent the final element in the array. So in other words, the maximum or the final index basically. So let's you have an array of 5 elements, then your final index or your upper bound is going to be 4, because you're going to use 4 to access that final element. In the constructor, I'm going to do a few checks here. I check to see if size is greater than 0, because we want a dynamic array which at least has one element, right? So if size is greater than 0, then we allocate a new array on the heap. Okay, we pass in size, so it's going to have that many elements. And as I mentioned, we store that address in elements, which is a pointer, and then upper bound is going to be size minus 1. Even if we construct an entity and pass in an argument of 1, this will still work. And we can construct an array right here on the heap, and that will have one element. And then the upper bound is going to be 0, because you can access that single element by using the subscript or the index 0. Otherwise, if you construct an entity by passing in a negative value or 0, then it's going to allocate an array on the heap that has one element. Okay, this is just a basic check, just for demonstration purposes. You can do it in a different way if you want. You can do a printout if you want, and so on. Now here is where we overload the subscript operator. I'll come back to the static value in a second. It has a formal parameter called subscript, and because it's a fundamental type in integer, I'm not passing in by reference. We're not passing in an object or something like that, so I'm just passing by value here. And again, this is going to return a reference to an integer, and this means we can use it on the left-hand side or the right-hand side of the assignment operator, and we'll look at an example in main shortly. Then I do a few checks again. If that subscript is greater than or equal to 0, remember with this we are not constructing a new array that has already been constructed, and we now want to access a particular index or a particular element. And of course you can use the index 0 to access the first element. So if it's greater than or equal to 0 and the subscript is less than or equal to the upper bound, then it's going to return this right here. So we use the elements pointer, and then we use the subscript notation to access that particular element on the heap. Otherwise, this is going to be out of bounds, so we print out index out of bounds, and then we are going to return this right here, which is a static integer. Okay, and we set that to -1 by default. You can do an easier check for this by using an assertion instead of doing if and else, but we haven't covered assertions and error checking yet, so we'll do that in a future lesson. And as I mentioned, we can use this on the left-hand side of an assignment operator, and this is going to return by reference. You don't want to return a local variable or a local integer by reference, and so we use the static variable instead, and that's also going to help for debugging. So that is what I return in the case where the index is out of bounds. Then down here we have the destructor, which is simply going to deallocate the array that element's pointer is pointing at. Finally, we get to main. I'll get back to this first statement later. Here I construct entity 1 and I pass in 5. And I have a for loop here. I start with int I equal to 0. If I is less than 5, then go and increment I. And then I can do the subscript operator with our custom type now, our entity. And you can see this is where the interesting thing happens. We can use that subscript operator with our own types and not just with the fundamental types. And that gives us a lot of flexibility in C++. And because this returns by reference, it's going to return an L value, meaning that we can have it on the left-hand side of the assignment operator, and then I can assign I plus 1. And then here I'm simply going to print those elements out again. Okay, so whereas here we are assigning, we are getting or fetching in this statement right here. And as we expect, that prints out 1, 2, 3, 4, and 5. Okay, this construction here is going to assign an array on the heap, and that's going to contain 5 elements. And then we simply assign values to those 5 elements, and here we simply print those out. Those if-else statements will make sure that we stay within bounds, so if I do something like this, I less than 6, when I right here is 5, that should be out of bounds. We can build and run, and that's what we get. It prints out 1, 2, 3, 4, 5, index out of bounds, and we get -1. Let's do something else now. Let's say I want to change this to 1. If we build and run, we'll get index out of bounds a couple of times, and 1, and then 5, 5, 5. Why is that? And that's because these go to I is less than 5, and the same with this one, I is less than 5. Also, if you try and do something like 0 or -5, then this will have one element, so it will print out 1, and because of those for loops we'll get a bunch of out of bounds errors. But this right here we can see works. And the same thing when you try and construct one with 0 elements, it's going to construct one with 1 element. But of course this is a bit of a mess now with all of those errors that we get because these don't match. So I is less than 5, that does not match with the amount of elements that we have or the array size. And that's why in the C++ 101 module I mentioned that you typically want to use some constant integer for the index. So I have a constant integer called size here, and I pass in 5. Then now I can change that size in one place instead of in 3 locations. Okay, change that to 3 and it will print out 1, 2, and 3. That is going to wrap up this lecture. I hope you found it interesting. Again, this is not something that you'll be using all the time. Especially as a beginner, you'll probably not be using this, but you may find it useful at some point and you may run into it, in someone else's code. Alright, I'll see you next time.